Just a reminder, what we did yesterday, guys, elastic, inelastic collisions, we classified collisions in one of those two ways. So we had two types of collisions in terms of kinetic energy. Elastic, in which kinetic energy was conserved. Inelastic, in which kinetic energy is not conserved. In other words, kinetic energy is lost. What happens, by the way, if we calculate the kinetic energy before and after, and we find that kinetic energy was gained? What happens? We made a mistake. We made a mistake somewhere. And there are situations where kinetic energy could be gained if there was some kind of explosion taking place, but you won't get a question asking you if one of those is elastic or inelastic. We can't classify explosions in that way. So for you guys, the kinetic energy will either stay the same, it's elastic, or it will decrease, it's inelastic. Momentum, by the way, we know this right from yesterday, momentum will always be conserved. It's going to stay the same no matter what. But kinetic energy may or may not be conserved. Now, we saw a couple shortcuts yesterday that we can kind of follow sometimes. If two objects collide and they stick together, we know for sure, 100%, there's no uncertainty with this at all. If they stick together, the collision must be inelastic. Yes, it must be inelastic. Now, you could prove that mathematically, and sometimes in a written response, you're asked to prove that mathematically. But you will find that the kinetic energy decreases every single time. If they bounce apart, it could be elastic or inelastic. We don't know what it is. We got to do the calculation. Calculate EKI, calculate EKF separately from one another, and then compare them. Now, odds are, if they bounce apart, it's probably still going to be, inelastic, right? We don't know that for sure, though, so we want to do that calculation. If in doubt, though, right, because 90% of the collisions that we have are inelastic, let's play the odds. If in doubt, we're going to guess inelastic. Yep, question?
If something like rebounded off another thing, and you got a speed coming out of it that was like greater than what it went into, you would be wrong, right?
Yes. Yes. So the question was, if you guys didn't hear this, if something rebounded off of a wall, let's say, and bounced off, you found the speed to be greater than what it was when it struck the wall, you've made a mistake. Unless there was some kind of explosion taking place, some kind of whatever to propel it away from the wall, then you cannot get a speed greater than what you started with, right? Because you're creating energy from nothing, if that's the case, right? It strikes at 5 meters per second, it comes off at 7 meters per second, unless there was some energy source that caused that, and then it wouldn't be isolated, right? Then that's not going to happen. You made a mistake. Yes. 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 Now, it is possible when you have a collision for one object to speed up, but something has to happen to the other object as well, right? Like the combination of them, the momentum remains the same. But if you strike a wall, like the kinetic energy of an individual object can increase, but the kinetic energy of the system can't increase. So if it strikes a wall and the wall doesn't go anywhere, well, the kinetic energy of the ball has to be either the same or less than it was when it struck.
Something at rest doesn't have kinetic.
That's right. Something at rest doesn't have kinetic energy.
Okay,
so right. That's right. Yeah, you can't just get it out of nowhere. Good. Good. All right. Let's do a quick little example. Example number 2 that we did not do yesterday, and then we'll let you work on that practice quiz that I told you I was going to post. Okay. This one says a 5 kilogram ball traveling at 0.98 meters per second at east collides with a 6 kilogram stationary ball. After the collision, the lighter one is going at 0.6, 50 degrees north of east. The heavier one is going at 0.63, 38 degrees south of east. Is it elastic or is it inelastic? Well, these bounce apart, right? As they bounce apart, we can't say conclusively without a calculation whether it's elastic or inelastic. If I had to guess, I would probably guess that it is inelastic. It likely will be inelastic, but we don't know that for sure. We got a 90% chance of guessing right. But I'd rather have a 100% chance of getting a question right, not 80 or 90%. So let's figure this out. Let's say EKI, oh, wait a second. Because it's south of east, they're north of east, I gotta do X and Y components, right? Funny angles. Don't like funny angles, right? No, we're not worried about that. I see a couple heads nodding there, no. No, we don't. Because this is a kinetic energy problem, and kinetic energy and speed are scalars, right? Let's just calculate EKI. There's one object that's moving. So this is its kinetic energy. It's 1/2 of 5 kilograms times initial speed of 0.98 meters per second. Okay, square that. Now, it is moving to the east, but I don't really care that it's moving to the east. Could be west, could be whatever. 0.98 meters per second, that's the important thing. 0.5 times 5 times 0.98 squared is 2.401 joules, which I guess we should round that to 2 digits, 2.4 joules. There's the initial kinetic energy. We expect the final kinetic energy likely to be less, but we don't know for sure until we do that calculation. Let's do it now. EKF is equal to 1/2 m1v1f squared plus 1/2 m2v2f squared, because there's two objects now, right? After the collision takes place. 1/2 of 5, the lighter one goes at 0.6. What about this north of east thing? Doesn't matter. For momentum, it always matters. For kinetic energy, it never matters. Plus 1/2 of 6 kilograms times 0.63. This isn't any harder than yesterday's example, is it? Even though yesterday's example was just a straightforward one-dimensional collision. We don't pay any attention to direction when we're doing kinetic energy. 0.5 times 5 times 0.6 squared plus 0.5 times 6 times 0.63 squared is 2.0907 joules, which we should round to 2 digits, 2.1 joules. Is this elastic or inelastic? This is inelastic because we lost kinetic energy. The final kinetic energy is less than the initial kinetic energy. That's what we were going to guess, right? And we would have been right. But we don't want to guess unless we have to. Yep. Yeah. Okay. Good question. How close do they have to? How close do they have to be considered inelastic or elastic or whatever? Well, we look at the number of sig figs. We look at all our data here. It's 2 sig figs. Final answers should be 2 sig figs. If this was 2.401, and let's say this was 2.39, it's not, but let's say it was 2.3967, that would round to 2.4. Even though those two numbers are to 3 or 4 digits are different, to 2 sig figs they would be the same, we would call that elastic. We would call that elastic to 2 sig figs. Now, if this was 2.3467, it would round to 2.3 joules, and we would call it inelastic. So we just go to the number of sig figs that we should, and that's our kind of cutoff as to whether they're the same values, close enough.
So they have to be the exact same value to the amount of sig figs.
Yeah, they'd have to be the exact same value to the right number of significant figures to be considered elastic. Now, I doubt you'll get a question where it's that close, but if you do, you know how to deal with it. I just posted practice quiz number 6 for you guys, which is on this stuff, elastic and inelastic collisions. Take a look at that now. Only 3 questions. There's quite a bit of words in these questions, but as like I've told you this before, right? Like usually most of those words don't matter, right? So find what's important. Skim the information, skim it, look at the question, and then go back and try to find the relevant information. Work on that now. If we have time, we'll go over that at the end of class here. All right, let's have a look at practice quiz number 6 here. I know we only have about 6 minutes left, but we should be able to get this finished up, I think, within the 6 minutes. If you're not quite finished, and there's only a couple of you that aren't quite finished, listen, it's going to be a freebie, right? You're just going to we'll go over it, pay attention as we go over it, and then submit your answers afterwards. So I'll give you the credit for that, okay? First question says, in a classroom demonstration, two identical low-friction dynamics carts are pushed toward each other, traveling at the same speed when they collide. Now that doesn't tell us anything about whether it's elastic or inelastic right now, because two different carts have the same speed. Coincidence, right? It's after they bounce back, that's what's important here, that they still have the same speed. Immediately after the collision, both of the carts come to a complete stop. So they were both moving, and then they come to a complete stop. The teacher challenges his students to describe the collision. Some of the students' descriptions are provided below, and here are these descriptions. We want to know which of these descriptions are correct, right? Appropriate for this collision, which ones are correct. Before the collision occurs, the carts have the same momentum. Is that true? But they have the same mass and they have the same speed. But momentum has direction. They do not have the same momentum. One has momentum to the right, one has momentum to the left. Before the collision occurs, they have the same kinetic energy. Is that correct? Yes, because same mass, same speed, direction doesn't matter. Is it an example of an elastic collision? No, kinetic energy was clearly lost here. They both had kinetic energy initially, and then afterwards, neither of them have kinetic energy, so all of the kinetic energy was lost. It is definitely not elastic, therefore it must be inelastic. 2 and 4 would be my correct, 2 and 4 would be my correct answer there. Now I'm not sure, you guys told me that my answer key was wrong for that. I'm not sure what I had for this one. This one was right? Okay, so C is our correct answer there. Next question. Momentum is classified as a blank quantity. That should be a gimme, right? Momentum is a vector quantity. In an inelastic collision, momentum is conserved. Momentum is always conserved. Always conserved if we have an isolated system. Kinetic energy is classified as a scalar quantity, and in an inelastic collision, it is not conserved. So inelastic, momentum is still conserved, but kinetic energy is not conserved. The answer is A. Is that what I had for the answer key on that one? Yeah. Yes? Okay, number 3 was the only one that was wrong, I guess. Man, there's a lot of stuff here. Holy. Remember what I've told you a million times, right? Just skim the information, read the question, and then go back, now that you know what you're looking for, and find the important stuff here. I'm not going to bother skimming that with you. I'm going to assume that you've already done that. Let's go to the question. I don't know where it is. It's gone. No, it's just gone. The collision that produces, well, we see the question, we just don't see the options here. The collision that produces a backscattered electron is classified as elastic or inelastic because there is change or no change in the kinetic energy, right? That's what we're looking for. So look at this, guys. The collision that produces the backscattered electron. So we're looking for information on this about the backscattered electron, right? We know what we're looking for. We're looking for the backscattered electron. Here's the paragraph about the backscattered electron. Some electrons from the beam reflect off of the specimen at the same speed at which they hit. The backscattered electron, right, that's the paragraph we're looking for, picks up these electrons. The backscattered electron detector picks up these electrons, so on and so on, right? If they reflect at the same speed, if we have one object before and one object after, and it's the same speed, is it not the same kinetic energy? Well, therefore, it is elastic. We would say that this is classified as an elastic because there is no change in the kinetic energy. Now, I don't see the options here. What option was that? B. So my answer would be B. What did I put for my answer key?
It doesn't say.
Oh, it didn't say? Maybe I just didn't do that one for some reason. Does that make sense, you guys? So there were no calculations in these, right? The calculation ones, they're all the same. this is what I wanted to show you in this little practice thingy here, because sometimes we get a little bit bothered if it's not a calculation, right? But we can handle it. Normally we would have quiz number 6 tomorrow, but because we have a unit assignment due tomorrow and we want to go over that tomorrow, we're not going to have a quiz number 6. I'll probably post that quiz number 6 for practice if you want, but we won't worry about actually completing it tomorrow. All right, that's it, guys.